Now, the application of a derivative. In 12th standard, we need to study three application of differentiation. The first one is rate of change. Rate of change means it is dy by dx only. Dy by dx is also defined as rate of change or marginal value. Rate of change or marginal value also derivative itself. Rate of change of y with respect to x, dy by dx, rate of change of y with respect to x or marginal value y with respect to x. So dy by dx means, now if there is no variable is specified with respect to no variable is specified, then the variable we consider as tan t, that is written here. Rate of change if no variable is specified means the variable must be with respect to tan t. Now few examples are taken. First question, volume of a cube is increasing at 9 centimeter cube per second. Volume is increasing at the rate of, this is the rate of change of volume of a cube. Find the rate of change of, question number 1, side of the cube, question number 2, surface area of the cube when side is equal to 10 centimeter. At a particular instant when side is equal to 10 centimeter, what is the rate of change of side and what is the surface area rate of change. Now for that, what is given here, rate of change of volume is given, dV by dt is given as 9 centimeter cube per second, that is given here. Now for the first question, volume of a cube is side cube where A is the side. Now differentiated with respect to time t, because here per second is given, so it means time is given. So dV by dt is equal to, t is the variable, 3a square into dA by dt. Now substitute dV by dt is 9, that is equal to 3 into side is given as 10, 10 square into dA by dt, simplifying dA by dt will come 3 upon 100 centimeter per second. So rate of change of side of the cube at an instant when the side is 10 centimeter is 3 upon 100 centimeter cube per second. Now similarly second part is what is the surface area. S is equal to 6a square, surface area of a cube, 6 into side square, that is ds by dt equal to 12a into dA by dt, that is 12 into side is given as 10, so 12 into 10 into dA by dt, just we calculated 3 upon 100, simplifying 3.6 centimeters square per second. So therefore surface area of the cube is increasing at the rate of 3.6 centimeters square per second. Now here the word increasing is given, that is why these all things are coming in increasing. If this is decreasing is given, then we will take a minus here, that we will see in the coming section. Now another question is, if c of x, cost function is given as, c means cost function, c of x is given as this function. Find the marginal cost when 3 units are produced. Marginal cost means derivative only. So means we differentiate with respect to x. 3 units are produced means the value of x is given as 3. So after differentiation, put x is equal to 3. Differentiated, putting x is equal to 3, you will get c dash 3 is equal to approximately 30.02 rupees. That much rupees you will get. Another question, a particle is moving along the curve 6y equal to x cube plus 2. This is the form a particle is moving. Find the points at which the ordinate means y coordinate, is changing 8 times as fast as abscissa. Abscissa means x coordinate. So here it is given that y coordinate is changing 8 times the x coordinate. So that is given. Given is dy by dt is equal to 8 times dx by dt. Therefore, this we are differentiating 6y is equal to x cube plus 2, that I am differentiating 6 into dv by dt is equal to 3x square into dx by dt, 2 derivative is 0. So now substituted 6 into dy by dt is given as 8 times dx by dt. Simplifying dx by dt cancel. You will get x is equal to plus or minus 4. Now when x is equal to 4 you put it here. When x is equal to 4 you put here, y will come 11. Now when x is equal to minus 4 you are putting y will come minus 31 by 3. So there are 2 points forming. One is 4 comma 11 and other is minus 4 comma minus 31 by 3. That are the 2 points. And the next question, a man of height 2 meter walks at a uniform speed of 5 km per hour from a lamp post which is 6 meter high. Find the rate of change of length of his shadow increasing. Means here a lamp post AB whose height is 6 meter. A man is standing at a particular distance away, suppose x distance away, and moving away means moving in this direction. X is moving, this man is moving in this direction, means this x is changing at the rate of 5 km per man moving rate, means this x is changing. This x is changing, that is 5 km per hour. Now what is the question is, this is the man, so since the light is here, so this is the shadow of the man. What is the rate of change of y, means dy by dt you have to calculate. So man moving rate is given, we have to find out his shadow moving rate. So here I took tan this angle theta, so in this right angle triangle and in this right angle triangle, tan theta remains same. So means 6 upon the big triangle, 6 upon this AE, that is x plus y, equal to in the smaller triangle 2 upon y, that is written here. Tan theta equal to 6 upon x plus y equal to 2 upon y. This you cross multiply and simplify, you will get 3y equal to x plus y, means 2y is equal to y brought 2y equal to x. Now differentiate dy by dt. Actually 2 into dy by dt, 2 I brought the right answer, so dy by dt will come half of rate of change of man's moving, that is half of 2.5 km per hour, means his shadow, length of his shadow is moving at, or length of his shadow is increasing at, it's increasing is asked, so length of his shadow is increasing at 2.5 km per hour. Man is moving at the rate of 5 km per hour, so his shadow is increasing at the rate of 2.5 km per hour. Now, next question, the volume of a sphere is decreasing at the rate of, this word decreasing is there, that is why dV by dt is given as minus 900 centimeter cube per second. This minus is because of decreasing. Negative means decreasing. Here no symbol is written, means positive increasing. Now the question is, find the rate of change of question number 1 radius, question number 2 surface area. When radius is 15 centimeter, this 15 centimeter you will use after differentiation only, everywhere like that. The value which is given at the end you will use only after differentiation. Now this is given, now volume formula is 4 by 3 pi r cube, differentiating with respect to t, dv by dt equal to 4 pi r square into dr by dt, because with respect to t, substituting 15 is given r, substituting dr by dt will come minus 1 by pi centimeter per second, means radius is decreasing, minus means the radius is decreasing at the rate of 1 upon 5 centimeter per second. Now surface area formula is 4 pi r square, implies differentiating dA by dt equal to 8 pi r into dr by dt. So 8 pi r into, so 8 pi into 15 into minus 1 by pi dr by dt is given. So we will get a minus 120 centimeter square per second, means surface area is decreasing at 120 centimeter square per second. Now the second application, increasing and decreasing function. Here what we are discussing is the intervals in which the graph of the function is increasing and decreasing. For example, one of the examples, sin x graph is well known. The sin x graph which you learned in 11th standard is the graph of sin x. Now you may see that the interval minus 3 pi by 2 minus pi by 2 graph is coming downward. Then minus pi by 2 to pi by 2 graph is increasing. Similarly decreasing, you see, minus pi by 2 to pi by 2 increasing. pi by 2 to 3 pi by 2 graph is decreasing. So without drawing the graph, we may say, now it is graph is drawn and say, now without drawing the graph with the help of differentiation, we may say in which of the intervals the graph is increasing and which of the intervals the graph is decreasing. So for that there are 4 steps to be followed. First, find derivative dy by dx and take dy by dx equal to 0. Why we are taking dy by dx equal to 0? Because first you will find out the critical point. A word is that critical point. Critical point. Critical point means, it means where is the turning. You see, this is a turning point. You see, this is a turning point. This is another turning point. This is another turning point, and this is another turning point. So, if you are drawing a tangent at the turning point, that always will be parallel to x-axis. Drawing tangent at a turning point, it will be always parallel to x-axis. So, at that point, the dy by dx, here slope of x-axis is 0, so dy by dx equal to 0. That is why we are putting dy by dx equal to 0, so that we get the turning point where the changes are happened, where that is also called critical point, where the changes actually happened, where the starting of increasing or ending of increasing or decreasing is there. So that is written here because slope of the tangent is parallel to x-axis, slope is 0. Now, after finding dy by dx put equal to 0, so you will get some critical points when you are putting dy by dx equal to 0. So the domain of the function, whatever the domain is there, all polynomial function minus infinity, sin x and cos x also minus infinity means the possible values of x which you can use. So divide the domain of the function into one or more intervals. Very easily you can make it. Here some of the example, we'll see that later. Now third step, intervals in which the derivative of the function is positive, greater than or equal to 0, implies f of x is increasing. Now here you see both are difference is coming, one is equal to symbol and other is without equal to symbol. If you use equal to symbol means use closed interval, means use only increasing, and if you are not using equal to symbol then strictly increasing. Here only increasing, here strictly increasing. In the case of strictly increasing, we will not use the critical points. That points we will avoid, we will use only open interval. That's all the difference. Strictly increasing use open interval and simply increasing means use closed interval. Now similarly, third case, this is for increasing and this is for decreasing. If f dash x is negative means less than or equal to 0, decreasing or strictly decreasing. Same meaning here also. One of the example, this is f of x. Now f dash x you will get put equal to 0, you solve it, it's a quadratic equation, solve it, you will get x is equal to -1 and -2. Since it is a polynomial, all real numbers we can use minus into infinity. I divide this -2 and -1 here, I use here, and this number line I divide it into 3 intervals, 1, 2, 3. Now any one of the interval you find out what is the sign of f dash x. So what I am going to do is I find out a number after this, after -1, 0 is there. There is a number 0. 0 I took and using f dash x, only using f dash x and see the sign. This is 0, this is 0, this is coming negative, that is negative. So here I am using any number, you will get positive, and here also I am using, then it will come negative. Here only alternate symbols will come. Only one of the sign you find out, so that we can write the rest. Now you will write how to write the method. F dash x is greater than or equal to 0, positive. F dash x is greater than or equal to 0 in closed interval -2 to closed interval -2 to -1 implies f of x is increasing. Closed interval is used because I used increasing. or f dash is greater than 0 in minus 2 to minus 1, same only I used open interval, then f of x is strictly increasing. Here sign of f dash x we are saying, and increasing decreasing we are saying at f of x. Sign of f dash x you will see, increasing or decreasing you say about f of x. Here also sign of f dash x less than 0, the remaining intervals this and this, so f dash x is negative in these two intervals, so decreasing. If we are using a strictly decreasing, only use open intervals at the critical points. Now there is another question, f of x equal to sin x plus cos x only up to this interval, that is why 0 to 2 pi is given. If specified, then that interval you will see. Here also f dash x I find out put equal to 0. If you are taking tan x will come 1, so x value is pi by 4 or pi by 4 because it contains all the 4 quadrant. Now 0 to 2 pi is divided into 3 parts here also, and if we are taking any number from 0 to pi by 4 means 0 to 45 degree, f dash x will come positive, then negative, positive. So same theory, f dash x less than 0, I not used equal to symbol here, in pi by 4 to pi by 4 implies f of x is strictly decreasing. Here equal to symbol is not there, that is strictly increasing. Similarly, f dash is greater than 0 in the remaining interval, f of x is strictly decreasing. Strictly decreasing, short it is written, strictly increasing. Positive means increasing, negative means decreasing. Similarly, another example, dy by dx, I find out product will be applied. E raised to minus x never can be 0, it can cancel. E raised to numbers never will be 0. So I eliminated, now x values is 0 or 2. Divided there also minus infinity to infinity, because this polynomial function and e raised to function domain is whole real number, that is why it is divided. Now 0 and 2 use. Now if we are finding using any number 0 to 2 here, this will come positive. Keep it in mind, e raised to any value is always positive, so no need to think about e raised to minus s, that is only always positive. Other part only you will see, so positive and the negatives will come. So y is strictly increasing, this you understand. Positive part, f dash is greater than 0, mean dy by dx is positive here, that is why strictly increasing 0 to 2 and strictly decreasing in the remaining interval minus infinity to 0 union 2 to infinity. Third application is maxima and minima. In second application, increasing and decreasing, we find out the intervals in which the function is increasing and decreasing, and there I shown y is equal to sin x. The function for sin x is increasing from minus pi by 2 to pi by 2, then decreasing from pi by 2 to 3 pi by 2, and without drawing the graph with the help of derivative we find out the intervals in which the function is increasing and decreasing. Here we can find out the maximum value and minimum value of a function without drawing the graph. Sin x graph we know the maximum value is 1 and minimum value is minus 1. Now we will find out without drawing the graph by two methods. One of the method is called with the help of first derivative test. Now maximum and minimum values are also reaching at the critical values or a turning point. So first we will find out the critical values by taking f dash is equal to 0, just like in increasing decreasing function. Now suppose a critical value is x is equal to a. Now f of x is maximum at that critical value x is equal to a if the left neighborhood of a and the right neighborhood of a, we will take two neighborhood of that number. Suppose 2 is the number, left neighborhood is 1.99 etc. and right neighborhood is 2.001 etc. And we will using f dash x. Now here left neighborhood is a minus h. Reduce a very small number from a, you will get h is tends to 0, a minus h. Left neighborhood is positive, f dash x is positive, and for the right neighborhood is f dash x is negative. Then we say that f of x is maximum at that critical value, and the local maximum of the maximum value, local maximum of that function at x is equal to a is f of a. Use this x is equal to a in the function. Local value means nearby that critical value you are getting a maximum value or minimum value. There may be more than one local maximum or local minimum. So that is why nearby that critical value you are getting a maximum value or minimum value. Now similarly, f of x is minimum at another critical point x is equal to b. Left neighborhood is negative and right neighborhood is positive. Here left neighborhood is positive, right neighborhood is negative. Left neighborhood is negative, right neighborhood is positive for a minimum. So we will say that local minimum is f of b. Here local maximum was f of a, local minimum is f of b. Now suppose another critical value x is equal to c we are taking, and we may observe that left neighborhood and right neighborhood are remains the same. Left neighborhood also positive, right neighborhood also positive, or left neighborhood and right neighborhood both are negative, means negative in both of the case or positive in both of the case. Sign is not changing. Here left positive, right negative. Here left negative, right positive. That is why we got maximum and minimum. Suppose left and right both are positive, left and right both are negative, then we say that the function is neither maximum nor minimum at that critical value. Such a point, a critical value is called point of inflection. Point of inflection. So we will say x is equal to c is a point of inflection. One example is there, f of x equal to x plus 3 whole cube into x minus 4 the whole raised to 4. You find out the derivative by product rule, simplifying and putting equal to 0, you will get 3 critical value, x is equal to 0 minus 3, 4. Now at x is equal to 0, left neighborhood, approximately I take minus 0.1. So when you are using this in f dash x here, minus 0.1, you will get a positive number. And right neighborhood you will get a negative answer. When you are putting minus 0.1 here, you will get a negative answer. So first positive, then negative, then f of x is maximum at x is equal to 0, and the local maximum is you put that x is equal to 0 in the given function. As you are putting x equal to 0 here, you will get 3 cube into minus 4 raised to 4. So the answer will come 6912 is the local maximum. Now at x is equal to minus 3, left neighborhood minus 3.1, you will get positive. Right neighborhood minus 2.9, there also you will get positive only. If you are substituting, you will get positive only. So both the signs are same. So f of x is neither maximum nor minimum at x is equal to minus 3. So the point of inflection is minus 3. X is equal to minus 3 is the point of inflection. Now the third critical point, x is equal to 4, left neighborhood negative, right neighborhood positive. We say that f of x is minimum at x is equal to 4, and local minimum value is f of 4 means x is equal to 4. You put it here, so you will get 0 is the local minimum. That is what is the first derivative test. Now let us see what is second derivative test. Here also you will find out the critical value by putting f dash is equal to 0. And then find the second derivative and use each critical value in f double dash x, each critical value. Now suppose x is equal to a is a critical value and you are putting in f double dash x. Suppose your answer is negative, means less than 0, f double dash x is negative, implies f of x is maximum at x is equal to a, or we'll say that local maximum is f of a. Now similarly another critical value x is equal to b, f double dash x is positive at x is equal to b, greater than 0. Then we will say f of x is minimum at x is equal to b, local minimum is f of b. And suppose a third critical value x is equal to 3, suppose second derivative you are getting as 0. Second derivative, suppose you are getting as 0 means not positive, not negative. So you will say that the second derivative test fails, you cannot find out it is maximum or minimum with that for second derivative. you have to use only the first derivative test and decide whether it is maximum or minimum. There is no method to calculate if the second derivative is zero at a critical value. One example is there, f of x is equal to 2x cube minus 21x square plus 36x minus 20. F dash x this much, 0 you are putting x equal to 1 and 6. Now second derivative of this is written 12x minus 42. If you are using f double dash of 1, x equal to 1 I use. So it is coming as negative. So means f of x is maximum, f of x is maximum and local maximum is f of 1. Put x is equal to 1, you will get minus 3. And similarly f double dash x, if you are putting it 6, you will get positive. So we will say that f of x is minimum and the local minimum value is f of 6. You put here x is equal to 6 here, you will get minus 128. Now some questions on it. One of example. Suppose f of x is given in a closed interval minus 1 to 4. This is a parabola which we studied in 11th standard, this type of parabola. So since it is given in a particular interval means the starting point of this number is minus 1 and ending point is 4. So there can be maximum and minimum values at these end points also. So that we are discussing here. So we are finding f dash is equal to 2x. So x is equal to 0 is the critical value. Second derivative, if you are finding it will come positive at x is equal to 0. So f of x is maximum at x is equal to 0. So the local minimum is 0. When you are putting x is equal to 0, you will get 0. And here also you must see that the minimum value of this graph is 0. Now, here it is locally is used because it is coming from a critical value. Now, since there is a closed interval, such cases, you have to use these two values also in the function. So f of minus 1, if I am putting, I will get 1. F of 4, you are getting 16. Now, when you are finding the maximum value and minimum value, you will see the local maximum values or minimum values also and these end points directly in the functions also. Now there are three values now, 1, 16 and 0. So the maximum value is 16 at x is equal to 4. This is absolute maximum we are saying. Absolute maximum we are saying. Absolute means overall if we are checking, the maximum value is 16 at x is equal to 4 and absolute minimum overall we are checking, throughout the graph we are checking, the minimum value is 0 at x is equal to 0. Now there are some weird problems. Suppose a cylinder of greatest curved surface area is inscribed in a cone. What will happen? Means a big cylinder is inscribing in a cone. So lot of cylinder you can inscribe in this cone. Then suppose you are keeping the maximum curved surface area of a cylinder you are inscribing in it. What will happen? So here the figure is there. So here R and H are the dimensions of the cone. X and Y are the dimensions of the cylinder. Since the question is greatest means maximum curved surface area. If you are cylinder, if you are inscribing like this, then what will happen to the curved surface area when it is maximum? Means differentiate in second derivative negative. That's the meaning of maximum. Now here I used since here x and y are the variables because we are going to find out the greatest surface area of the cylinder greatest surface area. So variables we will consider only for the cylinder and the cone dimensions we will consider as constant. Now you may see here RH. So since the full height is h, so this is remaining is h minus y. In this right angle triangle, tan theta equal to x upon h minus y, and the largest right angle triangle tan theta equal to r upon h. So that is written here. Tan theta equal to this, and you are getting it as x is equal to, from here you are getting x is equal to r upon h into h minus y, where x and y are the only variables. That is clearly written. Now CSA of a cylinder is A equal to 2 pi RH. Here R is x, radius of the cylinder is x, and height of the cylinder is y, that is 2 pi xy, that is 2 pi y into x value is substituted. You are getting 2 pi r upon h into hy minus y square. So differentiating, you will get y is equal to h upon 2. So when you are putting y equal to h upon 2 in this equation, x you will get r upon 2, and the second derivative is coming negative. So therefore area is maximum, and the maximum area of maximum curved surface area of such a cylinder is pi h r upon 2. So usually these type of questions are coming for case studies. So various questions may be there. Find the relation between x and y. Dimensions of the cylinder relation may be asked. Then you have to write the area in terms of any one of the variable, in terms of x or in terms of y. Then what is the derivative? Then what will happen when derivative is equal to 0? So various type of questions can be asked from application. That is why it is written. Another application, it is given to show that all rectangles inscribed in a circle, square has the maximum area. Means suppose if you are inscribing rectangles in a circle, square, when x and y are equal, then only maximum area will get. That you have to prove. So here r is a constant and x and y rectangles length and breadth are the dimensions. Applying Pythagoras theorem here, x square plus y square equal to 4r square. I find out y square, or you may find out x square also. Now area is length into breadth, area of the rectangle is length into breadth, the rectangle is written. Squaring x square y square because it is square, so substituting you will get a one variable equation. So I took it as f of x. Now differentiate in terms of x and put equal to 0, you will get x is equal to root 2r. Put x is equal to root 2r here in this here you substituting, y also will get root 2r, and the area will come x into y root 2r into root 2r, that is 2r square. So maximum area is and here also you are getting x and y are same. So rectangle is a square, both of x and y are same. So I can say this is x itself, so that we want to prove a square, and area will get 2r square also. And second derivative you are checking, you will get a negative itself. When you are putting x is equal to root 2r here, you will get negative. Now another question is cylinder of given volume and volume and minimum surface area. Surface area means total surface area. So means a cylinder is volume is given. Then you have to find out what will happen when you are differentiating surface area. You are minimizing surface area. So volume is pi r square h, find out v upon 4 pi r v upon pi r square. Now its total surface area of a cylinder is 2 pi r h, cylinder of given volume, so and the surface area. So surface area in this formula, substituted the value of h, you will get a is equal to, simplifying 2v upon r plus 2 pi r square. Differentiating now with respect to r, you will get, and put equal to 0, you will get a relation v is equal to 2 pi r cube. So there can be one of the relation. If you are putting the value of b back in that, you will get h is equal to 2r, means height of the cylinder is equal to diameter of the base, twice the radius. So second derivative you are checking, you will get positive, means area is minimum.